This is review for Chapter 14 exam. And we started first with the limits. And the limits is the study of values of a function to its designated point. And it can exist or nearly exist. So in this case, we have a polynomial, and we understand that the domain is negative infinity to infinity because it is continuous for all values of x. So therefore, if we want the limit as this function reaches 2, then we have substitute 2 for that value. So we would have 2 squared plus 8 times 2 minus 2. 4, 16 minus 2. Our limit is 18. In this case, we have a rational function. In a rational function, we cannot have 0 in denominators. So we have to first verify what the domain restrictions are. So we set the denominator equal to 0. I'm going to factor out an h. Set them equal to 0. So we've got this one here, which is what we need for the limit. So we know that x cannot equal 0 or negative 3. Therefore, we have to manipulate this to see where it's going. So what we do is factor to see if a removable point exists. So I'm going to have on my numerator h minus 3, h plus 3 over h times h plus 3. When we do that, then our obstruction cancels. So we have a removable point at negative 3. So now we use the limit as h approaches negative 3 of h minus 3 over h, which gives us negative 3 over negative 3. Well, we're going to have a negative 6 divided by negative 3, so our limit is a positive 2. Again, we have a rational function. So in this case, the domain of D cannot equal 3, and that's what we're looking at. So we're going to have to do the factoring again to see if there's a removable point. If not, we would then use a table. So on our denominator is d minus 3. In our numerator, we have a cubic, d minus 3 squared. So I would have d minus 3 times the square of the first term, opposite sign, their inner product, plus the square of the last, all over that denominator. The denominator terms cancel out, so we have another removable point. And now we can take the limit as d approaches 3 of our function d squared plus 3d plus 9. So this is going to be 3 squared plus 3 times the 3 plus the 9. And we get the limit of 27. It's not existing there, but the line only has a bleep. So that is what we would have. In this case here, we have 0 in denominator, because on the cosine of x, we know it cannot, x cannot equal pi halves or 3 pi halves, because that would be 0 for cosine. So we're going to use a table. And in this table, we would start with entering it our y equals. And we would say our x squared divided by cosine of x. And we would do our function, okay, because we have x going into some kind of large numbers, and we're going to say our window, because we're talking about 0, so we're going to say maybe negative pi fourths to positive pi fourths with a scale of, oh, it doesn't matter, we're going to say 1, we just want it open. And then we're going to say maybe a negative 5. Actually, I think I need a negative 9 and a positive 9. Let's see what that gives us. Yes, and we can see that our function, and we have it too high. So let's go with a negative 2 and a positive 2 and see how that graph looks. Perfect. We can see it approaches 0. So we're going to do a second calc value, and we see that at 0 we have 0. So that's what we have, is a 0. But how does that happen, right? It should not exist. Let me see if I wrote it right. X squared cosine x. And let me look at my mode. No, it's correct. So this is a rule in calculus about x divided by cosine x, or cosine x divided by cosine by x. It's going to be 0, like sine x over x is 1. So in this case, we're going to do a table, and we're going to go a little bit to the left of that 0. So we're talking radians. So we're going to say, and it's in radians, so we can put decimal 0, 1, decimal 0, 5, and decimal, because these are large. Let me do it the other way, close. 0, 1, which is 1 100ths. And then I can do 0, 0, 1, and 0, 0, 0, 1. Okay, and these are all in the negative. And that's just a small part going into the large. And I have it backwards, but that's okay. And then I'm going to have positive 0.0001, 0.001, and 0.01. Okay. Okay, because these are all in the part. So second count value, and I'm going to point negative 0.01, and I get 1, 2, 3, 4. There it is. Oops. There it is. 0.001. Then I'm going to have negative 0.001. And now I'm going to have 1 to the 6. So it's a 1, 2, 3, 4, 5, and 6. And then I'm going to do negative 0.1231. And I have to the negative 8. So 1, 2. So it's approaching 0, isn't it? I don't know why that's coming up, but that's what it's doing. 1, 2, 3, 4, 5, 6, 7, 8. There we go. And then we're doing 0.0001, and I get 1 to the negative 8, the same thing. So it's approaching 0 going this way, and it's getting further away from 0 going the other way. So the limit is 0. Now on this one is a picture, and we can see a gap. For a limit to exist, it must approach a value from the left and approach a value from the right, and these two must be identical in approach, and therefore the limit as x approaches c exists. Okay, so let's look at that. If I write this, the limit as x approaches 3, from the left, we're getting 3. And if we take that limit as x approaches 3 from the right for that function, we get 5. Well, they don't exist. Therefore, the limit as x approaches 3 for this f of x is a d and e, does not exist. All right. Well, here we have another rational, and we know that x cannot equal 0 for this rational function. And so therefore we make individual fractions of the denominator of 5x in denominator, and see what we can do. So we have the limit as x approaches 0 of x cubed divided by 5x plus 12x squared divided by 5x minus 5x divided by 5x. We're going to simplify, and I'm going to have x squared over 5 plus 12x over 5 minus 1. Well, if I put in 0, I get the limit of 1. So the limit of this guy is negative 1. Sorry about that. Negative 1. Okay. Now here we have a binomial. We still have a rational expression. And we know that x cannot equal negative 3. And they want us to to find the limit as x approaches -3. So we're going to do the factoring principle. And I have 15, and 15 is 5 times 3. And we need a negative in the middle, so 5 is negative and 3 is positive. So they cancel. I have a removable point. And now I'm substituting -3 and a -5. It gives us a -8. And that is our limit. Now we have this problem right here. Again, we have it's approaching 8, and 8 would make it 0 because we know x cannot equal 8 for this rational function. So we're going to factor this guy. Once we do that, we can see we have a removable point. So now we can take the limit as x approaches 8 of x plus 8. And we get 16. All right. Now here we have, again, our situation where we're reaching a like term. And in this case here, we're saying the limit as x approaches 0 is 0 over 0. But I believe we can probably factor out some things. And we know the rule that sine x over x is equal to 1. So I have 5 sine x over 7x. Well, this guy here is 1, so we get a limit of 5/7. And I'm pretty sure that all we could do was use the limit rule for the derivative on this one, but I just find it easier to take the shortcut. On this one, we can do a table because we know that tan of 0 is it is x, y over x, and y is 0 and x is 1, so it's 0. And the 9x is 0, so we have 0 over 0. We can't do that. So we're going to use the table feature. In our table feature, we know we want 0. And then these are all in radian. So we're going to go, this is a positive 0.001 and a positive 0.001. I'm sorry. And a positive 0.1. And, and then over here we do the negative of them. Oh, this is a 1. Okay, and we're going to see what we get. And we'll use a calculator for that to build our table. So in this case, we go to our y equals, and we're going to clear it out because we're wanting a limit. And I'm going to enter the 2 tan x, close parenthesis, divided by 9x. All right, and I'm going to graph it. I think I should be okay. There we go. You can see it's 0 as well. So we're going to go second. I'll do second trace. This is good. Second trace. And I want a negative 0.1. And I get, let me make a t-chart. So at negative 0.1, I get 0.0022. At negative 0.01, I get 0.12345 at negative 0.01. So you can see we're approaching 0. And then we're going at negative 0.123, I think is what I said. 2. Sorry. I just went to 2. And I'm almost there, aren't I? And I have 7 of them. So you know this is really, really approaching 0, because the negative on the exponent, e to the negative 7, means we have 7 zeros in front of that 0.2. So it's 1, 2, 3, 4, 5, 6, and this would be 0.2. So this is approaching 0, isn't it? And then we would have 0.001. Oh, and this is and so I'm going to have 0.001, and that's on the positive side, and we get the same number. So we're approaching 0. The limit is 0 by table. Now this problem here is making sure you understand that if we're looking for continuity, it is the domain of x and what it can and can't be. So in this case, we're only set the denominator equal to 0 for sides of exemption. So this is x squared minus 25 equals 0, x plus 5 minus 5 equals 0, therefore cannot equal 0. Therefore, x cannot equal negative 5, and x cannot equal 5. Now, the numerator has no impact on the domain, because you can have 0 in the numerator. So the only answer is continuous for all real numbers except negative 5 and 5. Now there's asking, when is it undefined? And that means exemptions to domain. And now we want when x is or equals. So we set the denominator equal to 0 and solve. And we have 3 terms, so we do grouping. So I'm going to do these two. This is x to the 3rd. And I'm going to do 3. And then I have this as a GCF. And then I have this. And these are all equal to 0. So I have x equals 1 or x equals, and I'm going to show you that one. I'm going to take the cube root. So, or x equals negative, the square root of negative 3. Cube root of negative. So these two are the exemptions to that function. So we want to find the derivative. In these two, we are looking for x is 8, and this is our rule. And our rule states that our derivative equals f of x minus f of c divided by x minus c for the limit. And then we'll take the limit. And I better put that in there. Let me see if I can make room. It's the limit as x approaches c is the derivative. So we're going to first take the derivative, find what f of 8 is. So we want f of 8. So let me do that. And I get 532. Okay, now I'm going to structure my problem. We're going to take the limit as x approaches 8, and we're going to have the x cubed plus 20 minus the 532 all over x minus 8. So that's going to give me x cubed minus 512 all over x minus 8. Now we're going to see if that 512, excuse me, I had an itchy eye. We get 64. So we know 512 is 8 cubed. All right. So we're going to do our F word. Now, a cubic is a base root minus base, open parentheses, square the first term, opposite sign, their inner product, plus square of the last term, all over the denominator. Now we can cancel out the common factor and take the limit as x approaches 8 because we've removed the problem. So now I'm going to have 8 squared plus 8 times the 8 plus the 64. It's a very large number, isn't it? 8 squared plus 8 times 8 plus the 64. 192 is my limit. It's approaching that from the left and the right. Now we have the same x equals 8, but we have a parabola. So we want to learn about our f of 8. We have 8 squared, 8 times 8 minus 3. $128 minus 3 is $125. All right. So we're going to have our limit as x approaches 8 of our f of x, which is x squared plus 8x minus 3 minus the 125, all divided by x minus 8. All right. So these two make 128. All right. So we're saying we've got to make sure it can be divisible by 8. So let's take our calculator because we know this functional thing works. Let me get my calculator. Where did it go? Oh, there it is. So on my calculator, I'm going to go 128 divided by 8. And I get 16. Well, 8 from 16 is 8, and I need 16 to be positive, and the 8 to be negative. So I'm going to have x plus 16, x minus 8, all over x minus 8. Those cancel. And now I can take the limit as x approaches 8. And that gives me 24. Okay. So I'm going to stop right there, and then I'll start up again.